Here's another example in Chapter 7, Inferential Statistics. See the actual example. Number 4. And seems to say the following. We have high turnover in call centers. We have 70 former employees. They want to know if they average tenure is no more than 2 years, no more. That means there's a direction. We don't care if it's less than, we care if it's more than. This is our first example of a non-directional test, sometimes called a one-tailed test, as you'll see, and use an alpha of standard 0.05. Okay, here's the data. Looks pretty much the same, males versus females, length of service. Okay, let's see what's going to happen here. I'm going to open it into StatCrunch. Of course, you can also do this in Excel, but I'm going to use StatCrunch. Get rid of the raw data. Let's go back to the hypothesis. So we're talking about averages. So we could use the Greek letter mu, which is like a U, but actually pronounced in Greece as me to make it even more confusing. And here we want to know if it's greater than or equal to 2. Let me see. Right? We're going to prove the claim has the average is no more than 2 years. Okay, that's a little tricky because definitely going to be a 2 here. And whatever you see here, this is going to be mu also. This is going to be the opposite of less than, which is greater than. And this is going to be a 2. My only question is, and the equal sign always goes on the H0, the null hypothesis. So this will be testing to see, is it less than, no more than 2 versus more than 2. I believe this is correct. No more than 2. We're testing to see that maybe it really is more than 2. So the no more implies like a less than or equal. So this is probably right. It is. Compute the test statistics. So let's go back to StatCrunch. Stat. It is an example of a t-stat because we don't know the standard deviation. We have one sample here with data. Length of years. Gender doesn't seem to be relevant here. So we don't need any of that. U equals, always have an equal sign here. This should be a 2. Automatically change to 2, and this should be greater than 2. Compute. We have minus 0.83. And we got it. P-value, just read it off. .79, which means it's going to be not significant because it's much bigger than 0.05. And test it. Well done. P-value is greater than alpha, which is 0.05. So we do not project. We continue to believe the null hypothesis. There is insufficient evidence to conclude the mean is greater than 2. We're going to continue to believe the average is lower than 2. In fact, the average was whatever. Let's just check that. The average was 1.89. So how can you prove it's bigger than 2 and the average is 1.89? So it's consistent. Get rid of that. Check answer. That is correct. And we're done. Oh, they ignored the male and female thing. So sharing.